Hello everyone, welcome to his physics YouTube channel. If this is your first time in this channel, here we make mathematics, statistics and physics easy. So you're in the right place. You're free to click the subscribe button and join the learning community. In this video, we're talking on the eigenvalues and the eigenvectors. Here, I'll show you how to derive the formula for eigenvalue and eigenvectors. I'll show you the formula for eigenvalues, the formula for eigenvector, and I'll use it to solve a system of 2 by 2 matrix. So watch the video to the end to get the full gist. Let's get to the video. So now, what is an eigenvalue? An eigenvalue is a factor from which an eigenvector is scaled, while an eigenvector is a vector which, when multiplied by a matrix A or B or C, remains in its original line. And from the introduction of what I said that I'm going to talk on how to find the eigenvalue and eigenvector of a matrix, of a 2 by 2 matrix and a 3 by 3 matrix. So now let's start with a 2 by 2 matrix. The question says, find the eigenvalues and corresponding eigenvectors of this matrix, matrix A, which is 2, 3, 4, and 1. Before we solve this problem, let me give you guys the gist of what is happening here. To solve for your eigenvalue, you use determinant of the matrix A minus lambda I equals to 0. This is what you use in solving for your eigenvalues. So, brackets, this for your eigenvalue. Now, to solve for your eigenvector, you multiply your vector A minus lambda I by your eigenvector equals to 0. This is what you use in solving for your eigenvectors. So now, usually, all my videos, I always outline the parameters and I define them. A stands for your matrix, which is given in the question. Lambda stands for your eigenvalue. I stands for your identity matrix. And your identity matrix for a 2 by 2 matrix is, so for a 2 by 2 matrix, identity matrix I equals to 1, 0, 0, 1. While for a 3 by 3 matrix, the identity matrix I equals to 1, 0, 0, 0, 1, 0, and 0, 0, 1. This is the identity matrix for a 2 by 2 matrix and a 3 by 3 matrix. So I stands for what? The identity matrix. We come here, A stands for your matrix, I stands for your eigenvalue. Sorry, lambda stands for your eigenvalue, I stands for your identity matrix, either 2 by 2 or 3 by 3, and your V stands for your eigenvector. So now let's attempt this question together. So we have our matrix A here. A equals to 2, 3, 4, and 1. This is our matrix A. And to find your eigenvalue first, what are we going to use? Determinant of A minus lambda I equals to 0, right? So now let's go together. Determinant of our A is what? 2, 3, 4, 1 minus lambda. What we're looking for, our eigenvalue, times what? The identity matrix. This is a 2 by 2 matrix. So our identity matrix will be 1, 0, 0, 1 equals to 0. Let's go. So we have 2, 3, 4, 1 minus 1 times 0. Sorry, lambda times 1. Lambda times 0, 0, 0, and lambda. We multiply this our identity matrix by our lambda. Now let's subtract these two together. If we subtract them, we have what? 2 minus lambda is 2 minus lambda. 3 minus 0, 3. 4 minus 0, 4. 1 minus lambda, 1 minus lambda. So what is it? We said is what? Determinant of A minus lambda I. We have found our A minus lambda I. This is our A, this is our lambda, this is our I. We have found A minus lambda I, and we got this. Now let's find the determinant of this and equal it to 0 to get our eigenvalue. So to find the diagonal to the 2 by 2 matrix, I've done the video on this before under adjoint to the matrix. So I'll drop the link at the end of the video so you can go back and refresh your memory. So to find your determinant of this matrix, this times this minus this times this. So 2 minus lambda times 1 minus lambda minus 3 times 4, which is what? 12, equals to 0, right? 2 minus, let's multiply these two together. 2 times 1, 2. 2 times minus lambda minus 2 lambda minus lambda times 1 minus lambda plus minus lambda times minus lambda is plus lambda square minus 12 equals to 0. Let's arrange this in a quadratic formula style. So we have lambda square 2 minus 12 is minus 10, but minus 2 lambda minus lambda is minus 3 lambda. 2 minus 12 is minus 10 equals to 0. Because of time, I won't be solving this. I will not stay the value because of time. I want to make the video short. It's already getting long. So if you solve this quadratically, our lambda 1 is 5 and our lambda 2 is minus 2. So therefore, our eigen, or let me clean here, eigenvalue now. Eigenvalues is lambda 1 equals to 5 and lambda 2 equals to minus 2. We have solved for section A of this question. We have found our eigenvalues. Now to find our eigenvectors. But first, let me give you guys a tip. To know if you're correct, if you're solving for eigenvalues of a 2 by 2 matrix, you're supposed to have 2 eigenvalues. But if you're solving for a 3 by 3 matrix, you have 3 eigenvalues. When I solve the second example, you'll understand better. Now let's find our eigenvectors. Our eigenvectors So now you find your eigenvectors from your individual eigenvalues. What does that mean? You find your eigenvector for when your lambda 1 equals to 5, and you also find your eigenvector for when your eigenvalue is minus 2. You find them individually. You do for 5 first, and do for minus 2. From the beginning of this video, I said to get to eigenvectors, you use a minus lambda I times your eigenvector equals to 0. Note, not determinant to just a minus lambda I times v equals to 0. Your a is what your matrix given, your lambda is your eigenvalue, your I is identity matrix, and your v is your eigenvector, which is what you're looking for. So now let's solve this. And also our v equals to x1, x2. Your eigenvector is x1 and x2 because it's a 2 by 2 matrix. So each eigenvalue will produce 2 eigenvectors. So note that down. Your eigenvector is x1 and x2. From here now, we can say our matrix A is what? Matrix A is, so now our matrix A is 2, 3, 4, 1 minus lambda. And for here, we're doing for when lambda is 5. So 5 bracket, the identity matrix 1, 0, 0, 1. This is inside the big bracket times your v. And what is our v? X1 and x2. Why? Because it's a 2 by 2 matrix and the eigenvectors will be 2. So we have x1, x2. Okay, so we have what? 2, 4, 3, 1 minus 5 times 1, 5, 5 times 0, 0, 5 times 0, 0, 5 times 1, 5. Then all this is the big bracket multiplied by what? X1 and okay. Now we subtract these two together. What do we have? We have that 2 minus 5 minus 3, 3 minus 0, 3, 4 minus 0, 4, and 1 minus 5 minus 4 times x1, x2 equals to 0. Now from here, we have found our a minus lambda I. This is our a minus lambda I, and this is our v, which is x1 and x2. Now let's derive our system of linear equations. This is a 2 by 2 matrix and a 1 by 1 matrix, row by column. You multiply them row by column. So 3 times minus 3 times x1 is minus 3x1 plus 3 times x2, 3x2 equals to 0. 4 times x1, 4x1 minus 4 times x2 minus 4x2 equals to 0. This is our system of linear equations. So now if we solve this equation simultaneously, our x1 is 1 and our x2 equals to 1. So therefore, our eigenvector for when our eigenvalue is equals to 5 is x1, x2, which is equals to 1, 1. This is our eigenvector for when our eigenvalue is 5. Now let's do it for when our eigenvalue is minus 2. So for when this equals to minus 2, right? What do we have? The same formula. A minus lambda I times V equals to 0. And our A is what? 2, 3, 4, 1 minus. Yeah, our lambda now is now minus 2. And there's already minus here. Or minus bracket minus 2 identity matrix, which is 1, 0, 0, 1. Right? Now, we have 2, 3, 4, 1 minus 2 times 1 minus 2 minus 2 times 0, 0 minus 2 times 0, 0 minus 2 times 1 minus 2. Don't forget, this is a minus lambda I. Let's put it in a bracket times what? V. And what is our V? X1, x2. Let's subtract these two together. If we subtract it, what do we have? We have that 2 minus minus 2, 4, 3 minus 0, 3, 4 minus 0, 4, 1 minus minus 2, 3 times what? X1, x2 equals to 0. We are moving slowly. So now let's multiply these two together. 4 times x1, 4x1, 3 times x2 plus 3x2 equals to 0, and 4 times x1, 4x1 plus 3 times x2, 3x2 equals to 0. If you solve these two pair of simultaneous equations, you solve them simultaneously, you get your x1 as 3 and your x2 as minus 4. So now finally I've gotten our eigenvectors for when your lambda is -2. So now the eigenvector v, which is what, x1 x2 is equals to 3 and -4. So this is your eigenvector for when lambda is -2, and this is your eigenvector for when lambda is 5. So we are done for solving the eigenvalues and eigenvectors of a 2 by 2 matrix. Now so we're done with this class. We just finished solving eigenvalues and eigenvectors of a 2 by 2 matrix. So this class was helpful for you. Please don't forget to subscribe and share the video. Also like the video and comment your review in the comment section. See you in my next video. Bye.